Aeromed verify.
Ready, light.
Aeromed, booster interlock to go.
Go.
Instrumentation, communications, the spacecraft's automatic stabilization and control system, ASCS, environmental control systems, all were go.
9, 8, 7, 6, 5, 4, 3, 2, 1. Roger, have a lift off and the clock is operating. How's your clock? Take my 7, base 7 on the way. Standing by to start the backup clock. Roger. 3, 2, 1, mark. Roger, and the backup clock is running. Roger, you look good here, Gordo. Roger, feels good, buddy. Great sport. 30 seconds and fuel is go. Oxygen is go. Cabin pressure on the top peg altimeter is working. Hey, Roger, you're looking beautiful. What an afterburner. That's the beauty of your clock doing thing.
As the spacecraft reached maximum dynamic pressure, all systems were go. As it rises, the vehicle is acquired and tracked by radar. Its automatic control is switched to the ground station. In the outer atmosphere, the vehicle is tilted toward the horizontal course. The escape tower remains in position to pull the spacecraft away from the launch vehicle in an emergency. At about 2 minutes 15 seconds of flight, BECO, or booster engine cutoff, will occur.
Sun is coming in the window now. Roger, we're standing by for your BECO. Roger.
Animation will show events beyond camera range.
Roger, BECO.
The sustainer engine drives Faith 7 toward orbital speed and altitude. When the spacecraft can escape with its own posigrade rockets, the tower is jettisoned.
And there goes the tower, and does she take off?
At 100 miles up and a speed of 17,544 miles per hour, SECO, sustainer engine cutoff, occurs as Faith 7 is inserted into orbit. 1 second later, it separates from the launch vehicle.
Accept Camp Green, SECO, I'm on aux damp. Going fly-by-wire. Everything is green here.
Faith 7 was inserted into orbit exactly in the center of its programmed envelope. Using fly-by-wire control, astronaut Cooper then turned the spacecraft so that it traveled with the retro rockets and the heat shield facing forward. This way, the retro rockets could be fired to reduce speed and end orbital flight if necessary. The small jets of hydrogen peroxide, which change the spacecraft's attitude, have no major effect on the path or velocity of the orbital flight. At 14 minutes 53 seconds, contact was made with the Canary Islands tracking station.
Phase 7, this is Canary Capcom. Roger, Canary Capcom, Phase 7, reading you loud and clear. What temperatures would you like, over?
Capcom is the capsule communicator in contact with the spacecraft at each tracking station. In addition, 28 ships and 172 aircraft were stationed around the world in pre-selected recovery areas. Contingency forces were also ready in the event of emergency landing.
Phase 7, this is Zanzibar Capcom. How do you read? Roger, Zanzibar, reading you loud and clear. Phase 7 here.
An added advantage of having a man performing in the spaceflight environment was indicated by astronaut Cooper's ability to keep a detailed record of his flight on the onboard tape recorder. For example, approaching his first night.
First night side, and I have a bright blue band, a thick diffused band of blue color, a bright blue band. The sun spread out very widely. Is setting now. And there it goes.
Phase 7, Perth has their lights on tonight. You might look for them and see.
Roger, I have the lights of Perth in sight, loud and clear.
From the perigee or low point of 100 miles over Bermuda to the apogee or high point of 166 miles over Australia, the first orbit was nearly perfect. Capcom at Guaymas, Mexico, gave astronaut Cooper his go for 7 orbits.
We're giving a go for 7 orbits. Roger. For 30, how many?
As many as you want.
Roger.
If all was well, in the 7th orbit, he would get a go for 17, then for the full 22. Meantime, he began the special experiments. The first was the use of this slow-scan television camera to relay pictures to the ground at the rate of 1 picture every 2 seconds. These pictures resulted from a transmission over Florida. 15 minutes before sunset on the 3rd orbit, Major Cooper prepared to eject this sphere, or beacon, for another experiment, to find out how well man can see flashing lights in space to help with rendezvous and docking maneuvers in future space programs.
And I am on fly-by-wire. I've armed the squib. Pitching up very, very slowly. And we'll deploy the flashing light minus 20 degree point. Flashing light is deployed.
Once ejected, the beacon assumed its own orbit, which kept it at varying distances from the spacecraft. Major Cooper was unable to find it on the 3rd orbit. However, on the next orbit, he saw the light clearly.
Quite bright, quite discernible. The order of a 2nd magnitude star now.
Beyond 10 or 12 miles, the flashing beacon became less discernible. In the 4th orbit also, the first of a series of tests were begun to measure radiation in space, where a belt of fission electrons trapped in the lower regions of the Earth's magnetic field would be penetrated by Faith 7 on orbits passing over eastern South America and the South Atlantic Ocean. Primarily, the measurements were made by 2 Geiger counters located on the retropack. One of the Geiger counters surveyed a hemisphere-shaped area unobstructed by the spacecraft and unaffected by radiation scattered by its structure. The other registered radiation directly in the path of travel. Trapped electrons spiraling along the Earth's magnetic flux lines were primarily the source of radiation. Several devices were provided to measure radiation piercing to the interior of the spacecraft. A pocket ion chamber, or dosimeter, a film patch attached to the hatch of the spacecraft, a photographic emulsion pack carried on the instrument panel, and 4 film patches worn beneath the astronaut's pressure suit, 1 in his helmet, the other 3 on his body. The packages contained 2 kinds of film, one sensitive to protons, one sensitive only to electrons. Both the nature and the amount of exterior and interior radiation at the Mercury orbit altitude were ascertained during the flight and found to be well below the level harmful to man. Astronaut Cooper was able to drink water successfully in his weightless condition, but he had some difficulty in transferring the water needed to make some of his packaged food edible. Experimental foods were freeze-dried and dehydrated so that adding water would restore their taste and consistency. Other foods were packaged in bite-sized bits. Small sandwiches, brownies, and other dessert-type foods were easily eaten. Other experiments were highly successful. For example, on the 6th orbit, astronaut Cooper clearly saw a 3 million candle power light shining up from Bomfontein, Africa. Such a light may be used to guide future moon explorers on their return to Earth. He carried out several experimental photographic assignments, such as taking pictures of the Earth's horizon or limb, which may also serve as a navigation fix in longer space flights. Another photographic research project involved use of a 35mm camera to shoot 2 dim light phenomena best observed beyond the Earth's atmosphere. One is called zodiacal light, believed to be a weak reflection of sunlight from free electrons and dust particles. The other dim light phenomenon he photographed was the Earth night airglow layer, a weak 3-colored band of light around the Earth. Time exposures with a 35mm camera will yield data on the height and intensity of these layers and on solar energy conversion processed in the upper atmosphere. Infrared photography of the Earth